Hello everyone, hope you guys are doing well. This video is for your prep for final exam. This is the solution for mock exam fall 2023. So in here you see that we have a picture where it's asking for lab rule violations. We can definitely see that this guy over here is drinking the chemicals, which is not allowed. And then the student over here doesn't seem to know what she's doing. She's just mixing everything, mixing whatever comes in her way without instructions. And then over here we have another student who is sniffing all of the chemicals, which is not the way. You should do it with your hands, and you gotta sweep the smell to get the smell. So this is not the right way of doing it, and neither of them have a lab coat. And they also, the girl over here, her hair is not that long, but if it's long hair, she needs to tie it. So that is the first question. And the next one, calculate the abundance of P34 and P32 considering the table below. So we know that over here is that mass number. For 32 it is 94.99, and then this one in here we got 0.01. If you add them up together you will get 95%, and we know everything needs to add up to 100%, right? So in here these two are adding up together to 5%. In order to do that, solve this equation, I can say this one is x, the other one is 5 minus x, and then we can find the answer. So 32 multiplied by 94.99 plus 33x plus 34 times 5 minus x, and then plus 36 times 0.01, and divide everything by 100 and make it equal to 32.09, and then solve for x, which will give you the final answer. We have done this many times, but this is the way to do it. So the first thing I would do, I will take the 100 to that side and I will solve for x. Now indicate the type of reaction. You can clearly see that the first one is double replacement, because these ions, they change the place, and this one is a combination or synthesis. Either way you can call them. This one is a combustion, and we have the next one again, the replacement, but this one is a single replacement, because we can see that bromine changed the place with F, but over here phosphate changed with OH, and they both swap the places. That's why the up one is the double and the bottom one is single replacement. Okay, now we move on to the next question. Over here we got like fragment of a periodic table, and we just need to find out which classes these elements do belong. We know that this one is alkali metal, while this magnesium, it is alkali earth metal. So you guys need to know all of the classes. And this is a transition metal, while this one is non-metal, and fluorine is non-metal as well, while this one, the last group, are the noble gases. This is something we have done many times. Now the next question is asking us to compare atomic radiuses of lithium and magnesium. Now I will give you your answer for this, but I'm just going to go over the theory first, and then you will get the answer yourself too. So lithium and magnesium. First of all, we can find from our periodic table, lithium has atomic mass 3, magnesium has 12. And radiuses, atomic radius trends is going like this, right? We know that as we go towards left and as we go towards the bottom, atomic radius increases. Now there are two reasons. Remember this. One of them is number of shells. As we go downwards, number of shells. As we go downwards, number of shell increase. Number of shells increase. And we know that if I keep increasing the shells, my atomic radius will increase. Atomic radius will increase because more shells, right? We will have bigger atomic radius. So before we go, what is atomic radius? Atomic radius is the distance from the center of the nucleus to the outermost shell, okay? That distance in here is the radius. Center of nucleus extending to outermost, meaning the last shell, outermost shell. That is atomic radius. Now, if I will keep increasing the number of shells, my atomic radius increases. That's why as we go down, we have first period, we have second period. The period number tells how many shells we have, right? The last period, which is 7th, is going to have 7 shells. So that's why it has the biggest atomic radius. Now there is a second factor in here, which is called effective nuclear charge. Now I want to explain you this quickly. So effective nuclear charge is what? Let's say I will have in here lithium, and I'm going to put beryllium in here. So lithium has 3 atomic number and beryllium has 4, right? Now in lithium we have 3 protons. So first shell, I've got 2 electrons, and the second shell I have just 1 electron, right? This is lithium. Now on the beryllium, I have 4 protons. I have 4 protons and then 2 electrons in the first shell and then 2 electrons in the second shell. Doesn't look good. Just gonna make it look pretty. So I've got this first shell and I've got the second shell. So in the first shell I've got 2 electrons, 1, 2, and then second shell I have 1 and 2. So 4 electrons. Now I want to ask, if you compare lithium and beryllium, which one will have more pulling force between the nucleus and outermost shell? Like if we compare this with this. Because we know that positive and negative attract each other, right? So if I have 3 protons and if I compare it with 4 protons, I know that 4 protons will pull closer, right? Will pull closer. That's why my atomic radius for beryllium is smaller, okay? And we call that effective nuclear charge, meaning that more protons do I have in the nucleus, my atomic radius will become smaller and smaller. And we know that as we go towards the left, effective nuclear charge decreases because we will have less protons on the left side, right? Because it's increasing towards right side, right? Do we agree? So that's why it's gonna go, as you go towards the left, effective nuclear charge decreases, and which is why atomic radius increases. Now we have two factors in here we talked. One of them is number of shells and the other one effective nuclear charge, right? Now as we go downwards, number of shell increases, that's why atomic radius increases. As we go towards the left, effective nuclear charge decreases, which is why atomic radius increases. But when you compare the two of them, the first factor is much more influential. Like it has more effective. Let's say more effective. Okay, so first factor, number of shells factor have more effect than number of effective nuclear charge. Okay, so we got that. Now when you compare now lithium with magnesium, I can see definitely that lithium has 2 shells, magnesium has 3 shells. Right away I know that magnesium has a bigger atomic radius. So radius I write like this. Radius of lithium is smaller than radius of magnesium. That's it. Now in the third part of the question, it's asking us to write the maximum excitement state, indicate the amount of unpaired electrons for phosphorus. Now phosphorus, we know that it has atomic number of 15. If I'll write the electronic configuration, I'm just going to write it, fill in the box. So I've got 1s, 2, and then I have 2s, 2, and then I have 2p, 6, and then I fill 3s, 2, and then I have 3p, 3, and that's where it finishes the 15 electrons. But after here, when I want to write maximum excitement state, I'm just gonna write the 3d. Normally we used to write the 4s, right? But 4s, when you write the maximum excitement state, when you have enough energy to put into the system, electron will go to the 3d, not 4s. Okay, now normal state, we had those cases where we would fill the 4s and then we would fill the 3d. That's a normal state, meaning minimum energy is provided. But when you have excited state, you're just gonna do 3s, 3p, 3d, and then you do 4s. Okay, now for this one, normal state, I'm just gonna write 3s, 3p, and then 4s. Okay, so remember this. Now if we have this, I'm gonna make an excitement state, meaning I will shift in the outermost shell. This is the third shell, is my last shell, right? So third shell is my last shell, so I'm gonna remove one of the paired electrons from here, and I'm gonna move it up to here, right? Now this is maximum excitement state. Now number of valence electrons is 5, and then number of valence electrons is 5, and then we also have the valency. In this case, valency will equal to 5, because in nonmetals we said that nonmetals number of unpaired electrons equals to valency. Okay, So we have in this case 1, 2, 3, 4, 5 valence electrons. That's why our valency is 5. Number of valence electrons, number of unpaired electrons is 5. And that is the answer. Okay, that's a long answer. You can make it shorter. Now, the next question. Identify if the statements about periodic tables below are true or false. Metals are good conductors of heat and electricity. They can be straightened into wires and possess metallic luster. If you check our PPT, you know that it is true. Non-metals are brittle and solid, opaque as thin sheets, and can be in a gas state. That is incorrect. They are not opaque. They are transparent as thin sheets. They can be in a gas state. This is true. And in solid state are brittle in solid state. That's correct. But opaque part is wrong, so which makes the whole expression false. Errors in readings taken from pH meter due to the faulty calibration of instrument is instrumentation, systematic error. This is true. We have done this with you. Like, for example, if I give you a scale, and we want to measure some weight on it, let's say we want to measure the liquid inside. The scale needs to report, for example, it has 0 plus or minus, for example, 2 grams of error. They reported. You can read it on the label of the scale, and we know that this is something associated with the scale itself. It is given to us, and this type of error is instrumentation error, which is also systematic error. Okay, systematic error. If something happened, so like your scale fell down or something, this number can go up to plus minus, I don't know, 4 grams. And then this is still again a systematic error. Now we continue. A student carries out thermal decomposition. Now this is a decomposition reaction. Now we used a scale, weighed, you see. We used a scale which has reported plus or minus 0.01. So we know that this is a systematic error. Systematic error. And then we got mass of crucible. So this is the cup, the crucible. Do you remember made from like white phosphor? So that crucible has a weight of 38.52. Now mass of empty crucible and copper 2 carbonate is 46.73. Mass of empty crucible and copper 2 oxide, it is 43.61. Now you need to deduct from here 46.73. You need to deduct 38.52, and this will give you 8.21 gram, which is the mass of copper 2 carbonate, which is this one. And then once they performed the reaction, they got this product, copper 2 oxide, which is this one, and they measured the weight, which is 43.61 with the crucible. So you still need to deduct the weight of crucible, which is again 46.73 minus 43.61, and you ended up getting 3.12 gram. Okay. Calculate the mass of copper oxide formed. Determine the mass percentage in the calculated mass. So they are just asking mass of copper 2 oxide formed, right? Which is this one in here. We got 3.12 gram of copper oxide, copper 2 oxide, and they're asking for us to find percentage relative uncertainty. Now this 0.01 is reported to us, so that's why we will say 0.01 So percentage relative uncertainty equals 0.01 divided by 3.12 times 100%. And use your calculator to find the value you reported in terms of percentage. Okay? And you can find it. Or the other way is just you can say 3.12 gram is 100%. And how much is 0.01 gram X%? And you can do this like that and get the answer. It will give you the same answer. Now, question 7, name the lab equipment provided below. You can easily say it. You need to know the name of all of the equipments, which is the test tube rack. Name the following compounds. Who will give you the names of all polyatomic ions? Polyatomic ions name tables. Do you remember those? It will be given to you, so you will be able to find the names of those. And we go to the question 9, but if you want me to do it, so sodium phosphate for the first one, the other one is sodium hydroxide, and the other one is potassium sulfate. Okay. Now, question 9. Element X is located in a third period and 7A group. So 7A group, meaning that it is P block. Do you remember the P block where halogens are located? So 7A group and a third period. We need to look at the periodic table. Right now I don't really have it here, but if I'll go back to this fragment fill in here. So this is, if you will check out the periodic table, so this is 4, 5, 6, this is 3, 4, 5, 6, 7, and 8. They are all A groups. If you will check it out, and this is a first period. First, this is the second, so it's a third period. It corresponds to phosphor. So, no, it's telling us the halogen. So if it's a halogen, third period, so fluorine, it's gonna be chlorine in here. So it is corresponding to chlorine. If you check it out, you will see it. So 7A group, and then third period, it falls into chlorine. And chlorine has atomic number of 17. So now let's go into our question. It says write down the electronic configuration. So we know that chlorine is 17, and we write it 1s2, 2s2, 2p6, 3s2, and 3p5. Even from electronic configuration you can see it, because 3 in here is the last shell, right? So we got first shell, second shell, 3 is the period number, third period, and when you add up 2 and 5 together, you will get 7, which is why it's a 7A group, because their electrons are located in S and P block. Okay, S and P. If it's located in D, then it is B group. B group is transition metals. Okay, so identify which element it is. Generate formula of molecule that X can form with barium metal. Okay, so barium is the second group element. You will see it. It's alkali earth metal. So alkali earth. You will see it. But so second group element will have the valency of 2, and chlorine has valency of 1, 3, 5, and 7. It has 3 different valencies, but when you make a bond with barium, as you see in here, to complete octet, chlorine needs to do what? Needs to get one more electron, right? Because it has 7 electrons. So it needs to add one more electron, and it will take it from barium, and barium will donate, because barium ends with, it is a sixth period, it ends with 6s2. It will donate 2 electrons to 3p5, and it will make 3p6. So it will donate these 2 electrons and have valency of 2, and chlorine will take 1 electron, it will have 1. So if you do cross on cross, the formula would be barium chlor 2, meaning that 2 electrons from barium, 1 went to one chlorine and 1 went to another chlorine, right? Altogether, the formula is barium chlor 2. Now that's the question 9. So we're in question 10. It's asking us to write normal, minimum, maximum excited states for sulfur. Indicate number of electrons to gain or lose the complete octet. Okay, so sulfur, first of all, has atomic number 16. That's what we know. Electronic configuration ends with 3s2 and 3p4 if you write it down. But I need to first of all throw you the electrons in the orbitals. So I'm gonna write this one in here, and I will zoom in. So 1s, 2, so it is 2s2, and then we got 2p6 is filled in that, and then we got 3s2, and then 3p 4, 1, 2, 3, and then 4. Now I told you that in normal state we put 4s after 3p, but in excited states, for excited states, we're gonna write 3d first, and then we write 4s. Okay, 1, 2, 3, 4. So now this one is normal state. Like if you want to write electronic configuration, just the electronic configuration in here. So first of all, let's look at here. How many unpaired electrons do I have? 1 and 2, right? So I have 2 unpaired electrons. Now valence electrons. Valence electrons meaning that the last shell. How many electrons do I have in the last shell? If you check it out, you would see it's 6. So 6 valence electrons. Okay. 2 unpaired electrons and 6 valence electrons. Now 2 unpaired electrons, it will give us that the valency equals to 2. And this is our normal state. Okay, this is the normal state. Now if I will add more energy to this, electrons are gonna start moving around, and we're gonna start with the paired ones. Now if you haven't written it, pause the video and write it, because I'm gonna write on the same picture the minimum state and maximum excited state. So now we go back in here. So we're gonna write now, I'm gonna write this stuff. I will now we got in here 3p again, so 1, 2, 3, and 4, right? And then in excited state, I told you that you need to write the 3d first. 1, 2, 3, 4. So the electron the paired electron in the last energetic shell, the very last one, is this first orbital you see in here. So what we're gonna do, we're gonna remove this electron from here, and we're gonna move it upward. Now we have still valence electron. Valence electrons is 6. Unpaired electrons is 4. So that's why our valency equals to 4 in this case. Okay? And in order to complete the octet in all of the cases, so you see how many electrons do I need to complete them? I have 6 electrons in here, right? Octet means 8, right? So it means that I need to get 2 electrons to complete octet in all of the cases, minimum excited or maximum excited state. Now I'm gonna write the same thing. So this is minimum excited state. Now I'm gonna do maximum excited state. So pause the video, write it down. I will do the same thing on this again. So now I will do maximum, and in maximum excited state, if I will zoom in, I'm gonna grab the next paired electron in here, and I will bring it upwards. Now if you check it out again, you will see that valence electron is still 6. This is correct. Number of unpaired electrons, though, it became 6. And that's why the valency became 6 too. Okay? So that's what you have. And in order to complete the octet, again guys, so if I have sulfur, I'm gonna write it like this. So we know that the first shell got 2, second shell got 8, and the next shell got 6, right? In order to make it octet, I need to gain 2 electrons. So in nonmetals, when we find the valency, we told you that you either nonmetals either lose electron or share electron. Okay? Now, sorry. So nonmetals make a bonding either by gaining electrons or sharing electrons. So first one, to complete octet, sulfur needs to gain 2 electrons. That's why when it gains, it has the valency of 2. Okay? But as you saw in maximum and minimum excited state, we had the valency of maximum, which is 6, and then minimum excited state is 4, right? And those cases are when nonmetals share the valence electrons, which is why we have 2 cases, 4 and 6 valences for sulfur. Okay, so valency 2 is obtained mostly when it's gaining electrons, and when they share, they have the valency of 4 and 6. Okay. Now it says compare the atomic rise of the following sulfur atom and ions. Now this is a good question again. I'm gonna write you in the center. We have what? We have sulfur, 16 protons. Sorry. We got 16 protons. And I'm gonna do it on all 3. So we got 16 protons on all of them. But we know that S sulfur, 16 protons, 16 electrons, S negative 2, 16 protons, 18 electrons. S plus 6 have 16 protons and 10 electrons. Now I want you to all think about this logically. So first one had how many shells? I got one shell, two shells, and three shells, right? So I'm gonna throw it in here. So 1, 2, and 3. I've got 3 shells, right? Now that is for sulfur 0. This is sulfur 0. And the next one, I just add 2 electrons. Do you see sulfur complete octet? In order to complete octet, we said 3s2 and, sorry, I'm going to write it underneath. So 3s2 and 3p4, right? So this was 6 electrons. If you add 2 more electrons, octet is complete. That's where you have 3 shells again. Now I'm gonna throw the 3 shells in here. So 1, 2, and 3. So we start filling the orbitals. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 electrons, and then the next shell we have 1, 2, 3, 4, 5, and 6. So 6 electrons in here. Now the second one I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then 1, 2, 3, 4, 5, 6, 7, 8. So this one is in here is sulfur 0. Sorry, sulfur 0 charge. This one is sulfur negative 2. And the next one we have in here is 1 shell, 2 shell, and 3 shell. Sorry. Let's see how many shells do I have here. So sulfur, it is 1s2, 1s2, 2s2, and 2p6, and that's it. So we only have 2 shells. Now if you will write those shells on top of them, so 1, 2, I mean filling the orbital, so 2 electrons on the first shell, so 3, 4, 5, 6, 7, 8, 9, and 10. So altogether we have 10 electrons here, and this is plus 6. So you guys remember what I told about the radiuses. It applies for both atoms and ions. Now look at it. Number of shells is the most important, Now in here, when you look at it, we can see clearly that S plus 6 ion has the smallest radius. So this one is smallest, because number of shells is the most important factor. Now in here, in both of these two, we have 3 shells. Now we need to look at it into detail. So S plus 0 has 16 electrons, S charge 0. S with charge of negative 2 has 18 electrons. Now, there is no effective nuclear charge difference because we're talking about the same element. So they have the same number of protons, right? Their protons did not change, but the number of electrons changed. So we know in this case that negative charge and negative charge, they push away each other. Do we agree? I believe you agree with me. And positive and negative attract each other. So in this case, in S negative 2, we added more electrons, and these negative electrons, they are pushing away from each other. They are not coming closer to each other, which is why it's increasing the atomic radius. Okay, so because now we're gonna write it in terms of words, number of shells is most important, and that's why S plus 6 has smallest radius, and this radius is ionic, okay? And then we have two of them, S0 and S negative 2. So this was the first reason for that. And the second reason is because we write it because of repulsion meaning pushing away, repulsion force between electrons, S negative 2 with 18 electrons will have bigger radius than S0. And that's that. And there is a similar question in 22. In 22, it is asking, compare the ionic radii of calcium and arsenic. But I need to quickly summarize this up before we go. So there are three factors that we discussed. One of them is number of shells. This one is the number one priority. First, if we compare two components, which has one of them has more shells, we know it has a bigger atomic or ionic radius in general. That's one of them. Second one, we had effective nuclear charge, meaning amount of protons in the center. If we compare different elements, yes, then we can talk about different elements, we can talk about it. But if you remember in our last question, we were talking about sulfur, which was the same element, right? But different ions. So we never talked about effective nuclear charge. And then the third one we had is repulsion force between electrons. So meaning that if we have more electrons, like if we get negative charge will always have a bigger atomic radius, because more electrons, they will repel each other and increase the ionic radius, okay? So three factors, you need to keep it in mind, okay? So the first, most important, is the number of shells. If you compare just two different atoms, you need to include the effective nuclear charge. But when you talk about ions, different ions, you also need to include repulsion force between the electrons. Now let's delve into question 22. Now compare the ionic radii of calcium and arsenic. Okay, so first of all, calcium and arsenic, they are both fourth period. Meaning both of them, they have four shells. But it's in neutral state, they are atoms, right? But we know that calcium has 20 and arsenic has 33 atomic number. So because we know from here that effective nuclear charge needs to be used in the argument, and because of that, calcium will have a bigger radius in 0 than arsenic. Because of the arsenic's bigger effective nuclear charge. More effective, okay? Now, when you compare their ionic radiuses, something changes. According to just the 0, we know even from our trends going from right to left, atomic radius increases. Calcium is located here, arsenic located there, and that's it. But trends is not the only reason. the reason of the trend is actually coming from the effective nuclear charge. Now, when you talk about ionic radiuses, we know that the metals tend to lose electron. They lose electron to gain octet. While arsenic, a semi-metal, most of the time gains electron. And if you will check out electronic configuration of calcium, it ends with ... 4s2, and then arsenic ends with ... 4s2 and 4p3, because you see 2 plus 3 gives you group 5, right? Arsenic is a 5a group, so 5a, and this is 2a group. So calcium loses 2 electrons, while arsenic gains 3 electrons to complete octet. To gain octet, for octet, this is what happens. Arsenic goes like this. Now this is 20, it makes it 18, and this is 33, makes it 36. Now electronic configuration of calcium ends up with, for calcium it ends up having electronic configuration 3s2 and 3p6 because it lost the 2 electrons, and arsenic is gonna end up having electronic configuration of 4s2 and 4p6. Now octet is complete. Right away from here, we can see that arsenic has more shells. Okay, so that's why arsenic ionic radius is gonna be bigger than radius of the calcium ion, because it has 3 shells while this one has 4 shells. Okay, that's the main reason in here. Also, there's one more factor, is effective, we have in here more repulsion force between the electrons. As you see, we added electrons, right? So meaning more repulsion force increased. So that's why, which increased the radius of arsenic from 0 to -3. But the main reason, guys, is number of shells. Okay, main reason is the number of shells. So keep this in mind, and it will be useful for you. Now, question 21 in here, explain why within a family such as the halogens, the ionic radius increases as the atomic number increases. So ionic radius, meaning that halogens is fluorine, they have negative charge. So fluorine, chlorine -1, bromine -1, and iodine -1. So normally we talked with you that atomic radius increases this way, right? And it also tells us the ionic radius increases as the atomic number increases, which actually makes sense too. Like the main reason is number of shells increases. That is the one. So because fluorine is second period, which means it has 2 shells, chlorine is third, this is fourth and fifth, so number of shells increases. Also on top of it, there is a repulsion force, because as you see, we added more electron into the shell, meaning more repulsion force within the shell increases radius. That is the reason. Okay. Now you can answer the other questions like 17, 18. I can help you out, but in this one, for example, lithium and potassium, all you need to do is just look at the trend where they are located. But the main thing in here, you need to understand that going downwards, meaning increasing the number of shells, has more effect than just decreasing the effective nuclear charge. Okay, more shells has more effect than decreasing effective nuclear charge. So that's why in here potassium will have a bigger radius than lithium. Okay, and you can check out all the other ones like that. Which of the following is the largest? Potassium atom, potassium ion. Potassium is the first group element, so it will have a charge +1. It will lose the electron, 1 electron in the last shell to complete the octet. And we have potassium ion, and we have a rubidium atom. So this is 0 and this is 0. We know that rubidium is located in the very bottom, meaning number of shells are really high. So rubidium is going to be the highest. But we also know that number of shells in potassium were in here for the 0 is 4 shells, because it ends with 4s1. And when it lost the electron, number of shells fell into 3 shells. Now it ends with 3s2 and 3p6. So that's why it's gonna be having a smaller radius than this one, and it's increasing like that, the radiuses. Which of the following is the largest? Chlorine atom, chlorine ion, or bromine atom? If we look at a periodic table, we will see that chlorine is located below, higher than bromine. So meaning bromine will have a big more shell. So right away we know that bromine is the biggest. And then we know that chlorine -1 took 1 more electron, meaning that more repulsion force between the electrons. So chlorine 1 falls into the middle, and chlorine 0 is the smallest. And then which of the following is the smallest? Lithium atom, lithium ion, sodium atom. So you can locate them. You see that lithium is located higher than sodium. So right away, because of the number of shells, sodium is bigger. And then lithium, before it had, lithium has two shells, because it ends with 2s1 and 1s2, 2s1. And when lithium ion appears, this 2s1 is gone, so lithium ion will have only 1 shell. So that's why lithium ion will be the smallest, and then it will be lithium and like that. So it should solve your atomic ionic radius questions like this. Now there is question 16. Sorry for kind of going backwards and forward. I want to kind of relate all the related questions. So for example, question in here 16, like this is everything in the PPT. I'm not going to bother and explaining with that. You can just go and check that out. Now in this portion from 12 to 15, it talks about ionization energy. Okay, so for ionization energy, choose the element with the greatest first ionization energy. Now first of all, we need to look at the elements in here. We have here calcium and we have aluminium. We know that calcium has electronic configuration ending with 3s2, 3p6 and 4s2. This is how it ends. And aluminium is 3s2 and 3p1. That's what we have. Now, in order to ionize, these metals need to lose electron. Okay, lose electron. So we have third shell in here in calcium and fourth shell, and in aluminium we have only third shell. So first ionization, if we have first ionization, calcium becomes calcium plus 1, right? So we lose one more electron. It becomes 3s2, 3p6, and 4s1. Calcium will easily give that electron because it's in the last shell. Aluminium, let's look at the aluminium right away. When we look at it, it has 3s2, and it will be 3s2, and it will be gone. Just 3p0, we don't even need to write it. So 3p0. When you look at it, we did not enter inner shell, meaning that this one had inner shell of 2p6, like this area, and the inner shell is 3s2 and 3p6 for calcium. Like this area is highly protected area. It's really hard to grab that electron from inner shell. That's why if we did not touch it, it's no problem, okay? Same thing in here, so highly protected. We did not touch it. Now, when we look at the trends, we know that the ionization energy increases in this fashion, right? So aluminum will have higher ionization energy. Right away we can see it because calcium is located here, aluminum is located there. So that's why in here we can see that aluminum is this one. Now you might be asking, why did we write all this stuff in here? We can just look at the trends and decide it. Bear with me, you will need this in the other exercises. So we have here then calcium and strontium. Calcium and strontium, if you will look at it, strontium is in the bottom, so calcium will have higher ionization energy. So in here, that's why we delete the strontium and calcium, and over here aluminum. And then we have helium and lithium. So lithium is located here, helium is located here. First ionization energy. Now I want you to look at the electronic configuration of lithium. So lithium, it is 1s2, 2s1. This is lithium. And helium is just 1s2. Now, in here, lithium can give out this one electron easily. But helium, on the other hand, only have one shell which is protected. It's fully protected. It doesn't want to give it out. That's why helium will have higher ionization energy, which is also reflects itself in the trend. Okay, that's why helium will be having the highest ionization energy, like among them all, even, because in the other ones, when we compare calcium and aluminium, or when we compare strontium, they have strontium is the second group element, right? And it ends with 5s2. So it can lose one electron in here very easily, become 5s1. It's not touching the inner shell in here, right? So meaning that strontium is safe to even give one more electron and make the charge of +2. But helium would not give any electron from outside to anyone. That's why it will have the highest ionization energy. Now the 13th question, which has a larger ionization energy, sodium or potassium? So sodium, potassium, you check the elements. Sodium is located higher, so sodium will have the higher according to trend. Explain different first ionization between lithium and beryllium. So lithium is located on the left, beryllium on the right. So beryllium will have higher because of the trend. So for question 15, I'm gonna make it a little simpler, so don't worry about this part. Let's just compare gallium with calcium. So gallium, if you will check out the periodic table, you will see that it's fourth period, and then it is 3A group. So electronic configuration ends 4s2 and 4p1. And then calcium, it ends with 4s2. Normally we know from the periodic table that ionization energy increases from bottom to top and left to right. That's what we know. But in this case, they are talking about third ionization energy. So that trend might not apply in this case. Because look at here. We have 3 electrons to lose in gallium from the last shell, valence electrons. Number of valence electrons is 3. But in here, number of valence electrons is 2. Okay, so first ionization, 1 electron is lost, gallium becomes +1, calcium becomes +1, no problem. It can give both of them. +2, calcium can also give +2, but now look at here, both of the electrons are gone. So for gallium though, only left 4s1. Now gallium can even push one more further and make it gallium +3 easily, but calcium +3 is almost impossible. So that's why calcium will have highest third ionization energy, because if you want to get calcium +3, you need to enter into the inner shell, meaning the third shell, which is highly protected, right? That's why gallium will have lower third ionization energy than calcium. But normally, if you just talk about ionization energies or just first ionization energy, of course, gallium will have higher than calcium because gallium is located towards the right. But because on the second one, again, first and also in the second too, and second ionization also gallium is bigger than calcium, but on the third one calcium is bigger than gallium. So I write here ionization energy 1, ionization energy 2. Gallium is bigger according to trend, but in the third one calcium is bigger than gallium. Well, this is kind of the hardest part of all those trends and everything. Now, question 11, it says, write the charge that each of the following atoms will have when it has a complete set of valence electrons. Now, this is super easy. Oxygen, you just need to find the location of oxygen, which is second period, and it is 6a group. And we know that atomic number is 8. Normally I can just write it 1s2, 2s2, and 2p4, or I can just find it by the group location, which is second group. You see the second group, second period, and 6a group, just add this 2 and 4, you can get it. So in order to complete octet, it needs to get 2 electrons. That's why the charge of oxygen will be -2. Now sodium has electronic configuration of, because it's a second period and 1a group, it will have the charge of +1 because electronic configuration ends with 1s2, 2s2, 2p6, and it will end with, it is a third period, so it ends with 3s1, right? It will lose that 1 electron, will have a +1 charge. Also, we know that first group and second group elements, they have positive charges. First group will have valency of 1, which is also +1 charge to get, right? To complete octet. And the second A group will have valency of 2, and the charge of the ion will be +2 to lose those 2 electrons. Now, fluorine, if you will write the electronic configuration, it is 9. I'm not going to find it through the period and group, but just write the full 1s2, 2s2, 2p, 5, right? Now, in order to complete the second shell, I need to add one electron, which makes the charge -1. And nitrogen, if you write it 1s2, 2s2, 2p3, you need to, in order to complete octet, you need to add 3 electrons, so nitrogen will be -3. And calcium ends with, we have done the calcium a lot, so 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. Now, in order to complete the octet, gotta lose these 2 electrons, so making it +2 charge. It's also 2a group, we already know it from that, so it will be +2 charge, valency of 2. Now, that is that. And then the questions in here, we can see it from that 4s2, 4p5, right away, it's a fourth period, and then 2 plus 5 gives you 7, and because it's s and p orbitals, so it's going to be 7a group. If you locate it, you will see that it is bromine we're talking about. Now write the electronic configuration of iron. So if you write the electronic configuration of iron, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. That's what we have. And then over here, because as you see, it's located, well, it has the last shell is what, 4, right? So it's a fourth period. And because 2 and 6 will give you 8, but because it is located in D, it will be 8b group. Okay, so we have that. Number of energetic levels is basically just 4 shells because it's fourth period. Number of electrons located in the highest energy level. So in this case, the highest energy level is 4, right? So we have we have 2 electrons, but also we have after here the 6. So B group we didn't really cover. Cover in that detail, but it says 8 electrons. But right now, let me show you for what happens with bromine in the previous question. So bromine has 4s2 and 4p5, right? How many electrons are located in the highest energy level? So this is the highest energy level. So right away we can see that it is a 7a, right? Because 2 plus 5 gives you 7, and because they are located in S and P, it is A group, 7a group element. And number of, again, how many energy levels is just fourth, because there are 4 shells, right? And that is that. Fill in the blanks. You can actually find this electron arrangement with complete outermost S and P levels is called octet, right? Octet. This is octet. For example, attraction atom, an atom has 4 electrons, is called what? You need to find that this is gotta be electronegativity, distance from the nucleus to the outermost. I already said it. This is atomic radius. You need to know all this stuff. Now questions 26, I'm gonna let you to do it on your own, because nitrogen ions +3, nitrogen ions +0, and -3. Right away we can see from here that when you have less electrons, you will have smaller radius. I can see it from here, but you need to give the reasoning. So the reason for this is more repulsion force between electrons. I told you I will let you, but I ended up doing it myself. And then over here we also have less shells, because if you check it, 1s2, 2s2, and 2p3 is 4. Sorry, number of shells is the same. it did not change. So it lost this 3 electrons for here, but it still has 2 shells. And more repulsion force between electrons, that's why it makes it bigger for nitrogen -3 than 0 and then +3, because this one has 4 electrons, while this one has 7 and this one has 10 electrons. The more electrons you have, the bigger the radius gets. Now this is distillation. You guys need to know all of the separation methods by now. Name the process in the picture below. This one is actually fractional, a very simple distillation in my opinion, but in the picture we told it it's a fractional distillation. The fractional distillations are normally like a lot more complicated, but for the being consistent, you're gonna write it as fractional distillation. Now, which substances can be taken for this separation method? We already told you many times: alcohol and water mixture. And we know that what type of a mixture. Now, in this case, this gotta be homogeneous. We know that we do not separate distillation methods for heterogeneous mixture, homogeneous. Now, in this case, we need to talk about volume and shape. As we can see, this is a solid state, and it has a definite volume, for example, 1 meter cube, and definite shape. Liquids, on the other hand, will have definite volume, but not definite shape, because if you will change the container, you put it into cup, you put it into something else, it will change the shape. And gases, neither definite shape nor definite volume. Everything changes in gas. Now this is the equipments you need to know. Name of all of the equipments. This is volumetric flask, which is used to make solutions. Now the next question, some of you said me, like, how can I memorize all this stuff? This is not a memorization. This is about knowing where the metals, non-metals, semi-metals are located in the periodic table. And if you know the properties of metals, such as, let's say, we know that they are conductive, right? Conductive. I can say that from here that aluminum is metal, so it will be conductive. This is not my prediction. Zinc gotta be conductive, iron, tin, lead, and sodium, they gotta be conductive. And copper, the same way, it's a transition metal, it is a metal, but I know that the carbon won't be. Okay, malleability, so I know that all the metals will be malleable, so it will be. Reactivity, I know from metals that are really highly reactive. We also did this in the lab. Only one of them, the highly reactive, was sodium. The other ones were not as reactive if they had any reaction. Carbon did not completely have any reaction. So, and then you need to classify the metal, non-metal, and semi-metal. And that's pretty much it. So good luck, guys. I'm sorry to make this long, but I believe everything is covered in this case. Just check out the video and you should be fine for the exam tomorrow.